Okay, so in the last class, we discussed some introduction towards simplification of Boolean expression using CAMAP. And in the last class, somebody asked about the SOP and the POS form, how we can fill that in CAMAP, how it is coming. Etc. So we'll discuss something about this SOP and POS example. Then we'll go to the simplification process. Okay. So SOP and POS. POS representation. So how we can represent the expression, Boolean expression in terms of SOP and POS. Now let's consider a truth table first. So let's consider three inputs A, B, C, and the output Y. So these are your inputs. This is your output. Okay. So we are having three inputs and one single output. And let's consider these three variables or three inputs are 0, 0, 0, 0, 1, sorry, 0, 0, 1, 0, 1, 0, 0, 1, 1. This we already discussed in the last class. Then 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1. Let's consider truth table like this, which means that you are varying these inputs A, B, C, okay, 0, 0, 0, 0, 0, 1, like that. And correspondingly, you will be getting output like, for example, 1, 0, then you're having 1, 1, then you're having 0, 0. So if we consider this truth table, how we can formulate SOP and POS form from this particular truth table? That we will explain, or this same output can be represented as in max or min terms. Okay? The same, this output can be expressed in terms of min terms and max. So how we can represent this in terms of min terms and max terms? That we will be discussing. Okay, so you are having your output y, which is in this form 1, 0, 1, 1, 0, 0, 1, 1. Okay, so in min term, if you are considering min terms, when you are considering min terms, you have to consider the ones in this question, this output. So these are the min terms. That is maximum value. Okay, and the zeros are the max terms. Okay, so when you are considering min terms, so first we'll analyze with the min terms. So with min terms, how we can represent this? Y of, can write ABC if your variable is ABC, A comma B comma C. That will be equal to, in terms of min terms, so you have to use sigma, that is for summation of products. Okay, sum of products. So we have to use summation symbol here. And small m, that is for min terms. and corresponding values of this value. So this is 0, 0, 0. Okay, input 0, 0, 0. So we will be having corresponding decimal position, which is equal to 0. Then you are having next one here. So you have to choose this input of this variable. So this is corresponding to 2, decimal equivalent 2. That is the position or address will be 2. And this one, next one is this. So this is nothing but 3. So this is 3. Now if you consider this one, so this one, so this will be having 4 and this is 2, so 6, right? So this is, and the last one is 7. It's 1, 1, 1 is 7. 1 into 2 raised to 0 plus 1 into 2 raised to 1 plus 1 into 2 raised to 1. So that will give you 7. So these are the minterms, representation of minterms. Okay? And this summation, as we know, this is this summation is coming from that sum of products form. Okay. So how we can express this in SOP form? So in SOP form, as you know, SOP means your 0 will be represented as a bar, okay, and 1 will be represented as a. So this is the same concept with the output y also. So if you want to get y, so y will be represented in terms of 1, and y bar will be 0. Okay. So if you want what is your value of y, then you have to take y equal to 1 position. And so the output to as y equal to 1, you have to choose corresponding positions for the variable. So y is equal to 1 that you have to choose if you want to get the output y. Okay. So otherwise, if you choose 0, then you will be getting y bar, complement of that. But we need the output y. So that we have to take 1 when you are considering SOP. That's why we are choosing this 1 min terms. In all these combinations, we are choosing this 1 value or high value only because we have to get this y. And when you are in the SOP form, your y will be given by 1 and y bar will be given by 0. So we will be considering those values. And if you take this into consideration and consider these positions 0, 2, 3, 6, and 7. So there will be having y equal to what is this first combination? First combination is this one 0, 0, 0. So 0 means A bar, B 0. It means that B is B bar. Then C also 0. So it will give you C bar. Okay. So in SOP form, 0 is A bar. So 0 here 0, 0, 0. That will give you A bar, B bar, C bar. The first one is A bar, B bar, C bar plus this is sum of products. Okay. And then second one 0, 1, 0. What is that? This 0 means in SOP 0 means A bar. 1 is A. So 0 first one is 0. 0 means A bar. Then B. Then C bar. So A bar, B, C. Similarly, third one, if you consider this one, third one, then what will happen? A bar, because here it is 0, so it is A bar, B, C. This is A bar, B, C. Similarly, you can go for the other two terms also. Then we'll get A, B, C bar plus the last one is A, B, C. SOP form, the sum of product is the canonical sum of product form, which means that it will be including all the variables. A, B, C in all terms. In all terms, we are having 3 variables. All the variables that we have considered. It may be in the normal form or it will be in the complex, in the complementary form. Okay? So it can be A or A bar, but all those variables will be present in this expression. A bar or B bar or C bar will be present in these terms. And that is why this is called as a canonical representation or canonical SOP. Okay. Now you can minimize this expression by using Boolean algebra. Okay, that is not in your syllabus. So this will be representing the canonical SOP form. Now, if we consider the simplification of this expression by using Boolean algebra, by using the laws associated with this Boolean algebra, then we will be getting the simplified form of this expression. Okay? So after simplification, I'm saying after simplification. So we will consider that by using K-map here. After simplification, using Boolean algebra, this you can write do as an homework. So that you will get y equal to the a bar c bar plus b. And this particular expression is called minimal SOP form. Minimal SOP form. Why it is called minimal SOP form? Because there is no much terms as compared to this canonical SOP form. This is the simplified form. Okay. So you can see this this contains only two variables. This term contains only two variables. This term contains only one variable. So it is the simplified form of the same expression as we represented in canonical SOP. Okay, so this is after simplification using Boolean algebra. We will try to do the same using the K-map. Okay, so let us check whether it is right or wrong. And if you consider now POS form, that is the SOP form. So now we'll consider POS form, POS, that is product of sum form. As you know, product of sum means you are having 0 as your A and 1 as your A bar. Okay, which means that in the same way you can consider 0 as your Y and 1 as your Y bar in case of POS. So now what you have to consider? Now you have to consider your zeros in the output if you want to get the value of output, that is Y. Okay, if you take 1, then it will give you Y bar. But we need a Y. We need Y. That is the output. Okay, so because of that, we have to consider these zeros in the output. So for SOP, sorry, for POS, we have to consider these zeros. These zeros we have to consider, that is in the output. And that will be given by, what are the positions here? So this is the first 0. Corresponding variables are 0, 0, 1. So which means that in POS form 0 means, in POS form 0 means A. Okay, so this is A, this is 0, this 0 means B, this 1 means C bar. So first one is A, B, C bar. So this will give, we will represent this, let's consider that expression first. Okay, so Y of ABC. So now we are talking about the output in terms of POS form. Okay, in POS form. So this is equal to, now we have to consider product of sum. So this pi, this is not that normal pi that you are using. Okay, this is the product symbol. This is we will be using pi like this. This is equal to 3.14. This is different. Okay, so this we will use for product. So this is pi. Means pi and capital M you have to use for max terms. So pi means that is the product of sums form. And this will be, first one is what is that value? First we have to consider values. So this one will be representing 0, 0, 1. That is nothing but 1. that is equal to 1, right? Because 1 into 2 raised to 0 will come. So this is 1. Then the second 0 is coming here. So this corresponding variable is this 1, 0, 0. 1, 0, 0 means 0 into 2 raised to 0 plus 0 into 2 raised to 1 plus 1 into 2 raised to 2. That is 4. So this one will be 4. Now the third one is this one, 101, that is 5. So now if you are checking these two expressions, you can see there is 0, 2, 3, 6, 7 here. And whatever terms which are not present in this particular min terms or for the case of SOP, okay. So those positions will be present in this max terms, by these max terms in POS form. Okay. Those positions or address which are absent when you consider the SOP form using these min terms, that will be present in the POS when you are representing the same in max terms, that will be present in. Okay, so by considering this, you can use the simplified form. Both will give you the same result. The max term that you can get after analyzing the truth table. Now, if we consider the same expression, this expression we can represent it like this: y equal to, in terms of post form. So y will be equal to, what is the first value? This is corresponding to 1. So that will be this one. So 0, 0, 1. 0, 0, 1 means 0 means A in case of a post. Okay. Product of some form, 0 means A. So A, B, C bar. That is the first one. A, B, C bar. So here we will be getting A, B, C bar. Sorry, in product of some form, we have to take core of this variable. A or B or C bar. And this has to be taken product. This is the next one. So 100. 100 means 1 means A bar. Here it is A bar. Okay. So this is A bar. Then this one is 0. This one is also 0. So A bar B C. A bar plus, sorry, A bar or B or C. You have to represent it as, pronounce it as or. So 101. Third one is 101. 101 means, this is 1 means A bar, 0 B, and 1 C bar. So A bar B C bar. A bar or B or C bar. So these are the max terms as expressed as POS, product of sum. And this particular form, which is called as canonical this is POS form, product of sum form, canonical product of sum form. And if you simplify this expression by using the Boolean algebra, then we will get the simplified form as A bar plus B, or A bar or B dot B or C bar. B or So you will be having two expressions here, y equal to ABC, y max terms of 145. Okay, and then we are having min terms which can be represented like this. So you can use either of these min terms or max term for simplification using CAMAP. Okay, so you can use zeros or you can use one for simplification purpose using CAMAP. Okay. Before we'll go to the simplification of these expressions for checking, first we will cover how we can simplify any expression using CAMAP. That first we have to discuss. So we'll consider that. So minimization. Simplification of Boolean expression. Boolean expression using CAMAP. So now you are having some basic ideas about SOP and POS, form in terms, max terms, all those things. Now we'll consider the grouping. Grouping. This is essential for simplification, and this is the first step towards that simplification. Now, how we can group in a CAMAP? Grouping means grouping of different cells. Okay, and remember that this grouping is possible in between the cells with one bit difference. Okay, this grouping is possible between the cells that are differed by one bit. So only those cells you have to group. You can group in the CAMAP. If the cells are having 2-bit differences, then you cannot group those cells. Okay, let's consider an example. If we consider a 3-variable CAMAP, we consider a 3-variable CAMAP like this. So let's consider so this is AB, this is C. And as you know, this is 0, 0, 0, 1, 1, 1, 1, 0, and this is 0, this is. Now let's consider you are having different. So we have taken here the SOP form, right? Because we have considered as products. Okay? So we have taken the POS form here. So let's consider you are having some one here, somewhere here, and somewhere here. And let's consider. So remember that grouping. First step is grouping will be possible as or I will just number of cells in a group follow the series, let's say 2, behind 2, then 4, then 8, etc. You can also consider 16. So it has to follow like this. It's a 2 raised to n form. You can consider. Okay. So that is this 2 raised to n form. The grouping number of cells in a group should be following this sequence, this particular series. So it can be 1. Number of cells in a group can be 1. Number of cells in a group can be 2. Number of cells in a group can be 4. So no groups will be having number of cells equal to 3. That is not allowed. And similarly, after 4, we are having 8. Okay, so no groups are having number of cells equal to 5, 6, 7. That is not allowed. So it should follow this series, and this series is nothing but 2 raised to n. Okay, 2 raised to n 0. You have to put n equal to 0, 1, 2, 3, etc. So accordingly, we have these values, and n is the number of variables as we said earlier. So if you take 2 raised to 3, then you will be getting maximum group size that is equal to 8. Okay, in between this 1, 2, 4, 8, any of those values can be equal to that the number of cells in any particular group. In that case, when you are having variable equal to 3. Okay, so if you are having number of variables which is equal to 4, then you can have maximum up to 16. Number of cells in a group can be 16. And then you can have 8, 4, 2, 1, all those values. You cannot have any group which is having number of cells which is larger than 16 when you are using 4 variables. And you will not be having any values, number of cells in between these numbers, 1, 2, 4, 8. Okay, so this number of cells in a group must follow this series 2 raised to n. So how we can group now? So if you are having, so first you have to start with the largest group. Okay, I mean you have to check the possibility with the largest number of cells. So in this case, this is a 3 by 3, sorry, 3 variable K-map. Okay, so the largest possible grouping or the number of cells, the largest possible number of cells in a group is 8, because you are using a 3 variable. So 2 raised to 3 is 8. So the maximum is 8. But we do not have 8 cells which are varying with 1 bit. Okay, as we said here, the cells should vary by 1. So first we have to consider, let's consider these 2 cells. Yes, 0. So their bit is changed from 0 to 1. Okay, this one is common. So this one is changed to 0 to 1. So only 1 bit is changing. So this condition is valid. And then you have to consider this condition, second condition, whether it is following this particular series. Okay, so it is when you are grouping these two, you are getting a group of cells with a group of 2 cells. So it is also following this condition because so that is possible. So this grouping is possible. And if you consider some other grouping, let's consider this one. Now you check what is the change in address, whether it is changing, the cell address is changing by 1 bit or not. So from that we can see when you are considering of these cells if you consider, they are deferred by a single unit, because you can see that this 0 is changed to 1. This 1 is remaining as such, and this 0 is changed. This one is changed. Here 1 is. So only 1 bit is changing. You are considering all these cells, and this one is common to all. So only 1 bit is changing all these cells, so that this condition is valid in that case. Okay. And the second condition, how many cells are there? 1, 2, 3, 4. 4 cells are there. So whether 4 is present here? Yes. So it is also allowed. This kind of grouping is also allowed. And as you can see, this is this particular also allowed because it is cells, the number of cells equal to that is allowed. And then we are having a change in their cell address with one bit change. So adjacent cells with the one bit change that is also allowed. So that kind of grouping is also. And now if you consider another one, for example, for the understand for better understanding. So let's consider this group. Let's say this as a group. So now you can see that the bit is changing by this address is changing by by a bit. This zero is changed to one. This one is changed to zero. So when you are moving from this cell to this cell, only one bit is changed. From this cell to this cell, this address is changing by one bit. So no problem with this condition. This condition is valid. Also, first condition is valid. That is the address is changing. But here you consider this sequence number of cells. If you consider one, two, three number of cells are in this group. Saying about this group. So in this group only three cells are there. So but our sequence is 1, 2, 4, 8. There is no 3 in this series. So that is not allowed. That particular group is not allowed. Now there is one another important so that so this is a B. Let's consider another one. I'm just I have just taken this one as an example. That this is just to say. So now if you consider this two, that whether these two can be grouped or not, that is possible or not. So in that case, you can check the same condition. Grouping is possible between cells that are differed by one bit. So if you consider this one is having 0 here, 0, 0 here, 0, 0, 0, that is total value. And then you consider this one, here we have having 1, 0 and 0. So only this 0 is changed. 0 is pushed. 0 is, and all other values are same. So this particular condition is valid because only one bit is changing. If you consider this cell and okay. And second condition, number of cells in that group should be 1, 2, 4, 8 case of. So this particular group is having two cells. So this condition is also valid. Also valid. So this grouping is possible. So if you are having cells which is at this ends of the gamma or the boundary, those cells also can be grouped together. So this is just like as a folding. So if you consider a sheet, if you fold like this, okay, a sheet and fold like this, so this part will be this side is going to touch, that is touch, whichever that you are giving. fold sheet. Then cells in this side will be touching cells. So if you are folding a paper, then that the cells on the bottom and top will touch each other. So that it is similar to that. So that these two cells will be like adjacent cells, and you can, so those which are coming at the boundaries that you can. Now let's consider as an example and just doing this one.
Sir, voice clear അല്ല.
വോയിസ് ബ്രേക്ക് ആണോ സൗണ്ട് വോയിസ് ഇല്ലാത്തതാണോ? ഹലോ ഹലോ
കൂടിയും കുറഞ്ഞും ഇരിക്കുകയാണ്.
ആ സോ so here we are having one. Let's consider this one is at and we are having only one here, then we can also group. Let's consider that the case of 4 by 4 variable camera. Consider a 4 camera. Okay, let's consider a 4 by 4 camera, 4 variable camera. So, 0, but on the so and let's consider some values, some midterms inside this. So let's consider a K-map like this, for example. So in this case, this is a 4 variable K-map, 4 variable, 4 variable K-map. So 4 variable means your maximum cells will be equal to 16. So you will be having sequence 1, 2, 3, sorry, 1, 2, 4, then 8, then 16. So this much of numbers of cells in each group can be possible. Okay, that is allowed, and each cell should be different by 1. So let's consider different groups here. So we have to do the first grouping, that is the maximum number of cells corresponding to maximum number of cells. So you check whether 16 cells can be grouped together in this particular case. That is not possible because we have vacant cells in here, so that 16 cells are not possible in particular case because we do not have any midterms in this. So that is not possible. Then the second one is 8, whether 8 is possible. So we have to check whether we have to do the maximum number of cells. We have to group maximum number of cells. And then we have to come to the lower values, lower, for example, into 8, then 8 to 4 like that. We have to proceed. So first we have to check whether 16 cells can be grouped together. That is not possible because we do not have 16 cells with the midterms equal to 16 cells which is they are having value. That is not possible here. Then we have to check whether 8 cells can be grouped together. Then we have to check in this scanner if there are 8 cells which are having change in each cells by unity or by 1 bit, and which also follows 8 cells. So this will be given by this particular case. You can see here. So this one is having 8 cells. Okay, so 8 cells are grouped together in particular case. And if you check the difference in their address in each cases, then you can see that all of them will have. Okay, so you can check in this direction or in this direction. It is so you can group that. So this is a case for 8 cell grouping, and then you have to check whether 4 cells grouping is available in this camera. So in the first look, you can see different possibilities for four cells. You have 2 cells in here, you can see here, and so for this particular case, I will just explain this. For example, you can have a four cell grouping like this, possible, right? Similarly, here also you can have a four. And if that is over, then you have to check for 2 cell grouping. Now it is all those values are grouped, so we don't have to care about the other values. Suppose if you are having, let's say, some different one more. So here also I'm considering the 4 variable camera. This is AB 0, 1. Let's consider these are having values 1 here, 1 here, and so in this case you can see these different values here. So how we can group in this case? Grouping. As you can see, we have to start from 16. 16 cells are not there with the midterm, which means that we do not have 16 cells with the value 1. That is not there. So then we have to come back to the 8, whether 8 cells are possible for grouping. That is also not possible because we do not have 8 cells with the change of 1 bit. That is not here. You can see that. And then we have to come to the 4 cells. Okay, whether 4 cells can be grouped together. So in a first look, you may not be observed that 4 cells. And then we can say grouping like this. This is these are the cells at the edges, and these also are at the edges. So you can group these two, so that you will be getting a group of 4 cells. And this is allowed because the bit change will be by unity. Also, we are having the value which is the series. So this is how we can group the cells at the end. That is very important. And then we have to look for the two cases. It's group with these two cells. So in first look also that is also not possible. You may group these two separately when you are considering this case, two cells. But here we have to consider these two cells. Then you are getting a group of two cells. And this one is not possible to group with anyone. So this will be acting as a single cell that will be. So you can have a separate cell that have any nearest cell. So this case we have to consider that as a group with the one cell. So this is how we will be grouping in this CAM app. Now we will consider an example how we can simplify this. And if you are not following this kind of maximum to minimum variation in the number of cells for in the grouping procedure, then you will not be ending up with the minimum uh, case, minimum variable case, because your Boolean expression will not be at the minimum number of variables. So you have to follow this particular direction from the maximum cells to the minimum. Then only your Boolean expression will be in the after. Okay. Now let us consider an example for this simplification process. So, uh, simplify simplify y of a b in terms 1, 3. So you have to understand that you are having ABC here, so which means that you need a 3 variable camera. So these are the midterms 1, 3, 4, 6. Now if you draw those variable camera, what is it? Here we have to consider terms. Here we will be having A, B. What is this? This is C bar, this is A bar, B bar, that is 0, 0. After. 0 1, that is a bar 1. This is how we'll be having the pattern. Now you have to fill these positions for midterms 1 3 4 6. Okay, so in this case you will be having variation 0 0 0 0. Then this is 4. That the addresses. So now we have to fill this midterms 1 3 4 6. 1 is coming here, 3, then 3 is here, then 4 6. Now you have to group. Start with 8 because you are having two variables, sorry, three variables. Means that your series will be 1 2 4 8. The maximum number of cells that you can group is 8. That is not here. You can see you are having total of 8 cells, and we do not have any midterms in this. So in that case, 8 is not, so this is not possible. Now consider 4. 4 is also not possible because we do not have any midterms which are or cells which are differed by 1 bit having 4 cells. So that is not possible. Not have any cells at the edges also. So this is also not possible. 2. Next one is 2. So 2 is possible. Yes, 2 is possible. This 2 over whole story. So this will be given. Now how we will take the values? Check what is common in this column and what is common in this row. So consider two different cells in this group and take what is common in both those cells. So here C is common for both cells. So C is present here. So C is common for both cells. So I can take C. Then in this side we are having A bar, B bar as well as A bar B. So in this A bar, B bar, A bar B, A bar is common for both cells. Both these cells, A bar is common. B bar is different. B is different. You can see that for this one is B bar, this one is B. So we cannot take that. What is common you have to take. A bar is common, B is not common, B bar and B they differ different. So only this A bar is common for both these cells. So I can take A bar. So this is A bar. Now I have to consider this particular case. What is common in this? C bar is common because both are in the same column. Okay, so I can write plus C bar because this is product of sum. That's why I'm writing like this. Sorry, sum of products, SOP form. We are considering midterms. So this is SOP form. So this is we have to consider like sum of products. That's why I'm writing this as dots. Sum. So in this CAMAP, you will be getting products. In each of the groups, you will be getting different products when you are considering sum of products. So here we will be having common term which is C bar, is C bar. Then we are having the common term, consider these two terms. So we are having common, B is changed to B bar. That is not common in these two sets. Only this A is common. A is common. I will take A. So A C bar is the second term. So each group you are having one is AC bar and the other one is A bar. So total output will be simplified form. Simplified by equal. A C bar plus A bar. What is the non-simplified form? That also we have to. So non, or I can say original form. Or we can say that the expression, canonical expression. What will be canonical form? Y equal to the same, each cells we have to consider in that case, because we need three variables in each terms when you are considering a canonical form. So the canonical SOP form will be given by y equal to, what is this value? First you have to consider this one. So this one will be a bar, a bar, bar, c, plus the next one, nothing but a bar, b, c. The next one is plus this one, that value a, b, c bar, plus last one, a, b bar. Okay, so this is the canonical form. This has been simplified into this by using CAMAC. The grouping, and we have simplified AC bar plus A bar. Now you can see that in this particular output you do not require any E. So you are reducing the variable here from 3 to 2. So you reduce it from, here we had a number of variables which is equal to 3 for this particular output. That has been reduced into 2 variable output. Which means that you need only 2 variables to achieve this particular output. Do not require this. So in that way, we can simplify the network. Also, we need only here we can see that this particular operation is OR. So only one OR gate is needed here. The one OR gate. And also we need this complementing actions. So we need a NOT gate also. So we need NOT gate. You can perform that. How it is going to be simplified? I hope you can do it by yourself. I will just show here for this time. I will just show you can simplify that. Yes, yes, okay. So the network with that canonical form, we have this network. So A bar V bar C, that is the first term that we need. A should go for to a NOT gate, okay, and that will give me A bar. And then I am having that B bar also, so I need a B also. And I also need a B bar, so I need, and this has to be passed to A bar will be B bar. I'm just taking AND gate. I will be getting what? A bar. So this is my A bar, my B bar. So A bar, B bar. First one is C. So C I have to take. And the next one is, so this two. Okay. Let's see. So this is how the circuit looks like. Then we have to take this. We have to take A B A bar B C. So I have to take this A bar and B C I have to keep. So this from this A bar I will be B from B I have to take one. Then I will connect those. Okay. And then the fourth one is ABC bar. So ABC bar means A B here, C bar I have to consider. I have to take that A is coming. C bar A B I have to. So then I have to take A I have taken, B I have to take. That will be this AND gate. And the last one is A B bar C bar. A B bar C bar means A is this one, B bar is here, then C bar. So I take each of that. So I am having A here. A I have taken already up to this. And from here I will take B bar from here. Then I am having that first one is B bar. B bar I have to take some. So you can see how many AND gates you have to connect. Then all these AND gate I have to connect to an OR gate with those OR operations. Plus, plus. So this is my Y without the simplification, which is means that it is in the canonical form. If you are making the circuit to get that particular output, then you have to consider all these components. Okay. So that we have to consider. Now at the same time, if you are simplified that using CAMAP or not right? But here we are using CAMAP, so you will be getting this kind of expression y equal to AC bar. So the same output y that you can get by simply if you are having two inputs A and C, if you connect those variables like read A and A bar, so someone can, so A C bar I have to take. Let me just version. So this is my AC bar. Then second one is A bar C. I have to take an gate, sorry, a note of this A, and this C I have to take. This is connected. These two lines are not connected. So this one is going to connect. That will be getting AC bar and are connected. So this circuit is simplified to this one. That's why we need multiply. So here we are doing it by CAML. Okay, so this is how we can simplify expression for simpler. Okay, here we need this is your a bar. Bar. We get a bar C. Or gate will be. So this is equivalent to this one. So this is how we'll simplify the expression. Through that we will be simplifying the circuit. Okay, let us do one more example. Then we'll, for example, same in terms. We'll do the same with the max term in the next class. So example 2, simplify the expression. Okay, consider simplify y equal to a bar b bar c plus a b bar b plus a b bar. So in this form also you can get expression to simplify. So this is not the previous one, like the previous one. This is like you have this that was in terms. Here we are having that in terms of sum of products. So okay. So how we can simplify this particular expression by using cap. So in this case, as you know, we do not need that particular expression in terms of midterms. You can directly simplify this. You are having having two variables here also. So okay, so this is your AB, this is C, will be given as C bar. Okay, so what are the expressions you are having in your post form? Sorry, SOP form. That is A bar, B bar, C. So correspondingly, we need one. So A bar, B bar is here, C is here. So this column you are having one. Then what is the second one? A bar, sorry, A B bar, C. A B bar. Where is A B bar? This one is A B bar. So in this row, and C is this one column. So here we are having. Then third one is A B C bar. A B is here, C bar is here. So A B C bar is this one. And A B C. A B C is A B. Now you can group this. So how we can group? You can take the maximum value. 8 is not possible. 4 is not possible. 2 is possible. Which are they? These two. Then so what is this one? One will be given as what is common in here. Here you are having A B bar. Here you are having A bar B bar. So B bar is common in the row. B bar is common in the row. And then we are having C, which is common. I am talking about this. So we will be getting bar bar C. One into two. And for this group, we'll be having common. What is common? This is C bar. C. So there is no common in that column wise. We are having common only in this row wise. AB is common to both. cells group. So we have B bar C plus so the total output will be simplified form, which means that SOP form. Or you can also say that minimal SOP form. Y equal to AB plus plus. What is the canonical form? Okay. SOP form that will be Y equal to this first one. You have to consider different values. First we will consider this one that we will be getting as A bar B bar C. A bar B bar plus. Then this one is A B C bar. A B C bar plus. Next this one. This one is A B C. A B plus. Next one is this one that is A B bar. So this is the canonical form that is simplified into y equal to AB plus B bar by using gamma. So this is how we simplify. In the next class, we will discuss how we can simplify the Boolean expression for four variable case, okay, four variable gamma. Then after that, we will discuss the POS form. Okay, here we are using minterms, and what will happen when you are using maximum? How we can simplify. The same procedure we had to follow, but these ones will be replaced by zeros in terms of when you are considering. Okay, so that is the only difference that will be there. And also in this cell address, we will be having A plus B and then A plus B bar like that in the column. So that we have to consider in the class. We are having